Welcome to Beyond X, where we blast past the limits of imagination. If you're new here, hit subscribe and ring the bell for mind-bending journeys. Today, what would happen if Earth fell into a black hole? Picture our blue planet spiraling toward a cosmic abyss where not even light can escape. Crushed instantly? Spaghettified? Something stranger? Buckle up, this is a wild ride. This is Beyond X. Let's dive in. First, meet the cosmic monster. A black hole isn't a vacuum cleaner. It's a region where gravity traps everything, even light. Formed when massive stars collapse into a singularity, surrounded by an event horizon, the point of no return. Once you cross the horizon, no signals, no messages, no hope. Black holes come in sizes, stellar mass, tens of suns, and supermassive, millions to billions of suns. For our thought experiment, we'll pick a 10 solar mass stellar black hole. Why? Because it's small enough to plausibly wander near our solar system, but still catastrophic. If active, a black hole can glow, an accretion disk brighter than 1,000 suns. Often you won't see the hole itself, only effects like gravitational lensing and a bright accretion ring. Now imagine that 10 solar mass candidate is drifting toward us. Let's watch the chaos unfold. Rogue black holes exist. Astronomers detected one wandering the Milky Way in recent years. But the odds of direct collision with Earth are astronomically low. Our solar system is stable. A 10 solar mass black hole has an event horizon only approximately 18 miles across. Tiny, but gravity dominates locally. Small enough to thread into the solar system, big enough to wreck Earth if it gets close. So for this video, we'll imagine a 10 solar mass interloper making a beeline toward us. Next, the long approach and the chaos that follows. Wake up to an alert. Astronomers spot a 10 solar mass black hole thousands of miles per second toward us. Even from far away, its gravity tugs at outer planets. Orbits wobble. Comets and asteroids get flung inward, raining debris on the inner system. City-sized craters, tsunamis, skies choked with dust. That's the warm-up. Coastlines flood as oceans slosh from gravitational disturbances. Governments warn, scientists scramble, people stare at the sky wondering, is this the end? As the black hole gets closer, the moon's dance goes wild, sending earthquakes and volcanic eruptions. Massive quakes, volcanoes eject ash, life faces immediate catastrophic hazards. The sun itself wobbles, destabilizing the whole solar system. Remember, you might not see the black hole directly, but you'll see lensing. Stars appear warped. If it's active and feeding on gas, an accretion disk lights up the sky. The stage is set. Earth is now being directly pulled. Within Mars's orbit, the black hole's gravity overtakes the sun's. Earth stops orbiting and spirals inward. The 10 solar mass event horizon is tiny, about 18 miles across, but its pull is relentless. Tidal forces stretch the side facing the black hole far more than the far side. Earth becomes elongated. If you were on the surface, you'd feel your feet pulled harder than your head. A strange, stretching sensation. Crust buckles, global earthquakes and volcanoes rip open, and the atmosphere roils. Oceans heat and boil as compression and friction heat the planet. Vapor plumes into space. Atmospheric gases are pulled into space or stripped away, darkening the sky. Surface life is extinguished long before we reach the horizon. Radiation, debris, and raw tidal stress. From far away, our clocks appear to slow, a dramatic time dilation effect. But on board Earth, time feels normal, which creates an eerie mismatch between inside and outside views. Now the planet is a shredded shell of rock, water, and air, and the event horizon is looming. A few thousand miles from the horizon, gravity warps space and time dramatically. To a distant watcher, Earth seems to freeze just outside the horizon, red-shifted into a faint smear. But for anyone still falling with Earth, you keep moving. Inside the horizon, all paths lead inward. General relativity shows every direction points toward the singularity. Escape is impossible. Tidal forces now intensify. Planet fragments elongate as they fall. The core compresses and heats, magnetic fields twist and snap. From afar, the final moments stretch into an eternity of slow motion and redshift. For those inside, the fall continues. The singularity awaits. What happens at the end? No one truly knows. Spaghettification. Tidal forces stretch everything into long, thin strands, atoms pulled into threads. Every atom, every rock, every drop of water elongates, racing toward the center at near light speed. At the singularity, density goes to extremes and our physics breaks down. We don't have definitive answers. Some theories suggest gateways to other universes. Others say information is fundamentally altered. Recent work and EHT images hint at complex horizons. Holographic ideas suggest information may be encoded at the boundary. Cutting-edge physics in 2025, from holography to quantum gravity, aims to decode singularities. For Earth, the finale is a millisecond of destruction. Planet reduced to a stream of particles, and beyond that glint, science and mystery merge. Could we have survived any of this? Spoiler, no. But let's entertain the sci-fi ideas briefly. Short answer, no. Tidal forces, radiation, and debris would kill life long before escape is possible. Even fantasy superships face impossible stresses. No known material could withstand this environment. Rogue black holes roam the galaxy, but collision odds with Earth are vanishingly small. Our solar system is safe for now. Future missions like LISA and continued EHT work will teach us more about black holes and their role in the cosmos. The idea of Earth falling into a black hole is terrifying and thrilling. It reminds us how small we are and how big our curiosity is. If your mind is spinning, smash like, subscribe, and tell us, do you think anything survives a singularity? Peace out.